let's look at interactions, which has to do with Newton's third law. For every action, there is an equal and opposite reaction. I have a few problems to show you. Our first example. A grocery sack can withstand a maximum of 300 newtons before it rips. Will a bag holding 22 kilograms of groceries that is lifted from the checkout counter at an acceleration of 5 meters per second squared hold? That's a pretty heavy bag of groceries, but let's see how to work the problem. So, the force is on the grocery bag. I'm going to draw it over here as my box. Now, the grocery bag has a force in the downwards direction, which is due to its weight. It has a force in the upwards direction due to the lift. So FL is going to be the force of the lift. L equals lift. FG you already know is weight. I'm going to write M is 22.0 kilograms. And we have an acceleration in the upwards direction of 5 meters per second squared. So A is 5 meters per second squared. Now our goal is to find out if the force of the lift is less than or greater than 300 newtons. And we'll see if the bag will break. So what we want to do is look at the summation of the forces on this object, mass times acceleration. So let's take this to the next page so we have room to work. So the summation of the forces on our grocery sack. We're going to lift in the upwards direction, and its weight is acting in the downwards direction. Those two forces will accelerate our grocery bag. So the force of the lift is equal to Fg, its weight, plus ma. Now remember, Fg is mass times gravity. So now I'm going to substitute Fg and put in mg for it. So now I have the force of the lift is equal to mg, the weight of the bag, plus ma. Do a little bit of factoring. My lift is equal to the mass times gravity plus the acceleration of the bag. We're ready for some numbers. So FL is equal to, our sack of groceries is 22 kilograms. Gravity is 9.8 meters per second squared. Acceleration was 5 meters per second squared. That was given to us. So now we have the force of the lift is equal to 22 kilograms times 14.8 meters per second squared. And that gives us a value of 325.6 newtons. Now the force of this lift is greater than the force that the sack can withstand. Remember, the grocery sack could only withstand 300 newtons. So that tells you sack will rip. So you either need to pick it up more slowly or get a better sack. Let's look at another example. This one, a race car has a mass of 700 kilograms. It starts from rest and travels 40 meters in 3 seconds. The car is uniformly accelerated during the entire time. What is the net force exerted on it? So, we have a mass of 700 kilograms. It starts from rest. VI is 0. Distance is 40 meters. And the time is 3 seconds. We don't know how fast it's going at the end of those 3 seconds, so we're going to have to use a different way of determining the acceleration, or at least different from what we've been using for a while. I know that V average is equal to d over t. So V average is 40 meters divided by 3 seconds. The average velocity of this car is 13.3 meters per second. Now, my goal is to find the net force. To do that, I need to find the acceleration. So that's what I'm doing. Should have told you that first. All right. Now I have V average. Remember, V average is equal to VF plus VI divided by 2. Now, VI is 0. We know V average, so VF is equal to 2 times V average, which is equal to 2 times, whoops, we'll do that. So VF is equal to 2 times 13.3 meters per second, which is 26.6 meters per second. Let's find acceleration. A is equal to VF minus VI over T. Our VF is 26.6 meters per second. VI is 0 divided by 3 seconds. Our acceleration, I'm going to round to 8.89 meters per second squared. Now that we have acceleration, we can determine the net force on the car. So F net, really just F equals ma. Remember, our car was 700 kilograms. I'm going to use 8.89. You can use the calculator value of your acceleration if you wish. If you use 8.89 with 700, our total force is 6,223 newtons. Net force is just the force that makes it accelerate. There you go. Let's look at one more. This is a boy and a girl playing tug-of-war. And of course they're on a frictionless surface. And the boy is 70 kilograms, the girl's 49. So mass of boy, 70. We don't know his acceleration, but we want to know it. And we know the mass of the girl, I'll use a different color, is 49 kilograms, and her acceleration is 3 meters per second squared. Now, the rope is pulling him this way. He's pulling it this way. For the girl, she's pulling the rope towards her, and the rope is pulling against her. We have equal but opposite reactions. So the force on the girl or the boy is equal to the mass times acceleration. So let's find the force on the girl. So the force on the girl is 49 kilograms just times her acceleration, 3 meters per second squared, which is 147 newtons. The force on the boy is equal, but yet in the opposite direction. Force of the boy is equal, I'm going to put absolute value signs, to the force on the girl. They're just in opposite directions. So now I'm going to use the force on the boy is 147 newtons, but his mass is different. It's 70 kilograms. So his acceleration is going to be different. So F divided by M will give us A. And we have 147 newtons divided by 70 kilograms gives us about 2.1 meters per second squared. We don't have to worry about the direction because they tell us within the question which direction it is. Okay? That's it for example problems. See you later.